So Player Piano is a book that I loved as a teenager, and it describes a dystopia where automation has replaced most jobs. So there's very few jobs left. In fact, it's a special thing to have a job. And what you realize reading this book is having a job is more important than just the thing that it produces. It's actually really important for human dignity. It's important for self-esteem. And you sort of wonder, if we really could automate everything, would we really be happy with that? And I went into a career as an AI researcher. It was kind of ironic, given the topic of this book. But it's amazingly prescient. It was written in 1948, and at that time, computers were actually human beings, right? So that job of being a computer has completely been replaced by computers. So I'm genuinely curious. I hope you guys will participate for a second. How many people does this resonate with? How many people think that automation will result in a significant job loss? I mean, how many people here? Anyone? See, this is a web utopia crowd. So I hope you'll bear with me for a second here. So what I'm going to argue here seems a little bit surprising on its face. What I'm going to say to most people, to most audiences, so what I'm going to say is that actually automation will cause an increase in jobs. And I was saying this to my dad before I got on the flight. I was saying I was going to argue this, and he's like, oh yeah, automation will cause an increase in jobs in AI research. It'll make a lot more people that build automated systems. And I actually have a more complicated point than that. I mean that automation will create all kinds of interesting jobs. So when I was creating this talk, I went back and I looked at the US unemployment rate since 1948, since the book was written. And it's sort of interesting. I think it has increased a little bit. And I learned a little bit about unemployment. It's been in the news a lot. And there's two types, right? There's frictional unemployment and structural unemployment. And so frictional unemployment is the unemployment that happens when you're looking for a job, right? So you might have a job for 10 years, and then it takes 3 months to find the next job. And so that leads to some natural unemployment. And it's generally thought that technology helps with this. In fact, there's a company here, Solvate, that I saw that works matching people to jobs. There's lots of technology that should reduce frictional unemployment over time, but there's a limit to what that can do. And then what's been in the news like crazy is structural unemployment, right? And that's when the workforce doesn't match the jobs available. And it's generally thought that technology should increase structural unemployment. So to be clear, what I'm actually arguing here is that structural unemployment there will be less structural unemployment due to technology. And if you think about it, again, that's pretty weird, right? I mean, there's jobs like transcription. So transcription is becoming increasingly automated. I honestly believe in 10 years, most transcription will be done by computers, and that's a $12 billion industry today. And this has happened to lots and lots of industries. Another way to look at employment is actually just the size of the US labor force, and that's increased a lot, right? So we can see historically, increased automation hasn't followed the pattern that Kurt Vonnegut was predicting. But we are on the cusp of something new, right? I mean, machine learning is now this buzzword that everybody knows about. I bet most of the audience here knows what machine learning is. That probably wasn't true 5 years ago. And data mining is this huge thing. And companies are moving all this data into the cloud. And most companies actually do automated stuff, right? If you get Amazon recommendations, you're using an AI system, right? If you search in Google, you're using an AI system. AI is everywhere, and that's only going to increase. But it's actually in the structure of the way AI has turned out to work that we see job creation that we didn't expect. So this is how most people think of AI, because this is how natural intelligence works, right? The way kids learn language is incredible. I have a 6-year-old cousin who's a Portuguese to English translator, and he's better than any computer, right? And he learned that through totally natural inputs, right? I mean, he just walks around the world, he hears Portuguese, he hears English, he learns both languages. I mean, no one handed this kid a dictionary, right? And so we sort of imagine, how does Google Translate work? We think, oh, it just sort of crawls the web, and it sees some English, and it sees some Portuguese, and it figures out sort of naturally to translate between the two. I will tell you, that is not the case. The way computers learn is totally different, right? It's like an extreme version of this classroom you're seeing here, right? It's super, super structured learning. So the way these kids look at examples and they go through dictionaries and sort of the way you learned maybe Portuguese in school, computers do a far, far more extreme version of that, where they get fed millions and millions of examples. And if you actually go talk to Google and you say, why do you have a state-of-the-art translation system today? What happened? They will tell you our algorithms are not that advanced. They're not as advanced as some of the algorithms that we even saw in early 2000, but the advantage that we have is a humongous parallel corpus, where people have labeled this English word corresponds to this Portuguese word, and they've done it for lots and lots of languages, and that massive amount of human data collection is what's led to the mass adoption of artificial intelligence, and that's all we see out on the horizon, right? That's the kind of artificial intelligence that's going to happen over the next 10, 20 years, right? The transcription systems that are built are going to be built on top of tons and tons and tons of human annotated data. And here's just one graph. Almost every research paper on artificial intelligence has a graph like this, right? The x-axis here is the amount of data that was fed into a system. The y-axis here is the error rate. And each line here is a different algorithm, right? So the one on top is a slightly less good algorithm than the one on the bottom. The individual algorithms don't really matter. It's the amount of data that got fed in. And you can see that there's still a long way to go, right? It looks like if we extended this graph way out to the right, the algorithm might get better and better and better. In fact, it does, right? And so these companies get this insatiable desire for labeled data, and they hire thousands of people to label data, to feed information into these computers so that they can automate better, right? These kinds of jobs actually didn't exist before. And again, I know I'm speaking to an audience that might think, oh, these aren't that interesting jobs, these aren't exciting jobs, these are kind of bad jobs. But trust me, most audiences would not have this reaction. Most audiences would be thrilled that there are jobs available that they can do. And Leila will talk far more about that, right? But if we go to even Iowa, but a refugee camp, they will be so excited to have real jobs available. And so what's happening here is actually a different version of automation than in the popular mind, right? This is actually a robot that lives in my office. It's an AnyBot. And it does office work sometimes, right? It sort of greets people as they come in. And it's a little bit different than we imagine in the Jetsons. It's actually controlled by a human being halfway around the world, and their face shows up in that screen that you can see on top, that little screen. And if you think about it, it's actually creating a job, right, to have this robot drive around and greet people as they come in. And it would be really hard to, even if you could build an automated system that could greet people, they might not like not having a human being here, right? The fact that there's a human being that can feel emotion and react is really, really important. So hopefully I convinced you that automation could lead to more jobs. And to talk about why that's important, I'm with Leila Janah, who is an expert on technology and developing world interaction.
Thanks. So we are witnessing a tremendous surge in human potential. The UN released a report recently that predicted that in the next 30 years, more people will receive a formal education than in all of human history. Back in the 70s, the great design thinker E.F. Schumacher said that our biggest problem in the next century would be the global moron shortage. Across the world, young people are grabbing at every chance they can to learn to read and write. 1.5 billion people around the world now speak English. 90% of the planet is literate. But at the same time, there's a tragic lack of work among the people who need it most. In Africa, nearly 150 million young people are unemployed or working in low-income jobs that still keep them poor. And in India, at least 130 million skilled people live in rural areas far from big cities and are forced to spend their most productive years outside of their home villages, in vast urban slums on the peripheries of these major cities, hoping to make enough money to support their families back home. And the end result of this tragic lack of work is that young people are turning to crime and violence as a way to make ends meet. In Africa, most militia groups pay young people to join them. If you live in a place where unemployment is 70%, as it is in much of the continent, and where most jobs don't pay enough to escape poverty, joining a militia doesn't sound all that bad. Traditionally, the approach to this kind of poverty has been handouts in some form or another. We spend $120 billion on foreign aid every year to help people like this young man, Mohammed, who I met in a Kenyan refugee camp last summer. In Mohammed's camp, which is the largest in the world, it's a bunch of Somali refugees living in a dusty part of Kenya, Abu Sayyaf is actively recruiting new terrorists from this staggering number of unemployed young men. Handouts are the wrong way to go. They force us to overlook the biggest human resource on the planet, which is the brain power at the bottom of the economic pyramid. Kids like Mohammed speak English, they use Facebook Zero on their cheap cell phones, and they don't want our charity. They want a job. Well, this is a photo of the biggest job creator there ever was, the factory assembly line. Henry Ford's innovation took the production of a highly complex machine, the automobile, and broke it down into small tasks that any person with a little bit of training could do. And the 20th century saw this logic applied to every kind of manufacturing. In China and Southeast Asia, sewing machines have empowered millions of women to escape poverty by working in garment factories. But big factories can't exist in most of the places where poor people live. Because to build a factory, you need ways to bring raw materials in and move finished product out. In other words, you need good roads and waterways. You need grid power. You need customs officials who aren't going to hold up your orders. And to pay for all of this, you usually have to create economies of scale with lots of people working in the same place at one time. So that was Assembly Line 1.0, but since we're at a conference with 2.0 in the title, let's talk about what one of my friends called the sewing machine of the future, the cheap laptop. Thanks to Moore's law, the cost of computing devices has gone down dramatically. The newest netbook out of China costs $65. There are at least 1 billion computers in the world, and 200 million were sold last year. Within the next few years, almost everyone on the planet will have access to a basic computing device. And many of them will be used in the places you'd least expect, like rural Haiti. And they'll be connected to new fiber optic cables like the 2 that landed in East Africa this year, or 3G networks, or satellite dishes like this one, which is on the roof of the center I just showed you, and shares the roof with some cook stoves. And what that means is that the assembly line of the future doesn't require 5,000 people to report to the same location. People living in poor and rural communities around the world can do tasks from small computer centers. As outsourcing matures as an industry, more and more work is moving into the cloud and enabling workers anywhere to earn money. The internet is reducing the friction of collaboration across different time zones and with a highly distributed workforce. And most excitingly, it enables organizations like ours to tap a new kind of worker, such as Pratibha Rajak, who's a young woman in India and now the primary breadwinner in her family in a country where rural women are a highly oppressed group. Or these villagers in rural Kenya who live 2 hours from the nearest city but close to good schools. Or even groups of refugees in Mohammed's refugee camp, which has a small computer lab. This is a photo I took last summer during my visit of Mohammed showing his friends how to do tasks on CrowdFlower's platform. They can earn 5 times the average wage in the refugee camp by doing micro work, and most of them have a high school education. All of them speak good English. We now have around 900 people like Pratibha and Mohammed verifying business listings, moderating content for social networks, and completing short-form transcription and translation work as full-time workers. Earlier this year, we worked with CrowdFlower to set up a text message-based 911 system after the Haitian earthquake. We received tens of thousands of messages requesting emergency assistance, and we trained 50 Haitian people in a rural community called Mirabelais to translate them into English so that aid workers from the Red Cross could respond. Many of the messages required a grasp of Haitian geography and couldn't have been accurately translated by a computer. So what we've done in Haiti, in Asia, and in Africa shows that if we think about poor people as productive assets, we have access to 4 billion supercomputers that have been lying idle for the last few years. The future of work is about inclusion. It's about lowering the barriers we've erected that prevent masses of people from helping us solve the data problems that Lukas alluded to earlier. For the first time in history, we have the means to tap a new workforce and solve poverty at the same time. Thanks.
Great.